Hey YouTube, welcome back. Today we have a new video. Today we'll talk about what are load balancers. So websites get traffic jams too, I guess, as you see on the street by a lot of cars. And luckily they have a digital traffic cop. And this traffic cop, we call it a load balancer. And today we will see exactly how it works and how it keeps sites fast and reliable. So first, we need to know why should we care. So whether you're building a simple project or the next Netflix system, load balancers let you add servers on the fly, survive crashes, and keep response times snappy. So let's break down. First, what is a load balancer? Let's say that we have a client and we have a distributed system. So we have multiple servers that serves our clients. Okay. So we need to put something in between the client and the servers to first distribute the loads across these servers and also make sure that no server is overwhelmed with requests and no server is underutilized, and also to also to keep the cache of each server, because the load balancer will keep the cache of its server, so the clients, whenever the clients try to ask for the same request, it will get pretty fast. So again, a load balancer sits in front of a group of servers, as you can see here. Okay. Every incoming request, like think of it as a customer, every incoming request that hits the load balancer will pick that request. It will pick also a healthy server and forwards the request to it. No single servers will get overwhelmed with requests. So what are the benefits that we get from this one? We get 4 benefits. The first thing, we have high availability. So if one server goes down or one server crashes, the load balancer will stop send to it any requests. Instead, it will send to other services. Next, we have scalability. Like let's say that you on Black Friday and you have a huge traffic, you just add more servers and the load balancer will distribute the request to those servers. Also, it's great in the performance since basically it balanced work means no slow check, no slow check out lines. So we make sure that no server is either overwhelmed those requests. Also, it's easy to maintain, because take one server offline or for updates, the users won't even notice what's going on, because the traffic is already redirected to different server. Okay, so we have different types of load balancers that we need to talk about. The first thing, we have hardware load balancer, which like a special box in data center. It's a fancy dedicated traffic light control. And next we have a software load balancer. It runs on normal servers like Nginx, for example. It's a traffic officer with a smartphone app, for example. Next, we have a layer 4 or transport. This one chooses a server using IP plus port. It's basically it's sorting mail by zip code only, for example. We have layer 7 or application. It looks at HTTP info like URL and path. It's sorting mail by full address and name, for example. And most modern apps use a software balancer because it's cheap, flexible, and it's a cloud friendly. So this is the most one that's been used. So next we need to talk about how load balancers works. So there is multiple algorithms that achieve the balancing functionality. First, we have round robin, which deal requests one by one to each server. On this video, I'll talk high level on the algorithms. I guess in the future we might create a video which is only dedicated to load balancers algorithms. We have least connection, which sends the next request to whoever has the shortest queue. We have weighted round robin or weighted, which is a bigger servers will get more work. There is an IP hash. This one is take the same user to the same server, which is helpful for logins, for example. Okay, so load balancers have some extra power as well. It's great in SSL and TLS termination, like balancer does the heavy math of HTTPS, so servers can relax. We have a sticky session. It keeps a user on the same server when needed. It has also auto-scaling. In the cloud, a new server launches and the auto-scaling register when traffic spikes. Also, the greater security. It's some balancers add web applications, firewall rules, or block DDoS flaws. We can talk about some real-life use cases. And I would say the real-life use case of load balancer is like, you can count them. It's a lot. We talk about the e-commerce sale, like if you have a sudden surge, balancer will spread shoppers across many servers to make sure that everyone can shop. It's a great also in live sports stream. Let's say that there is a streaming for an important football match, like the final of the Champions League. Basically, thousands join at kickoffs, for example, and the load balancer will keep the video smooth because it will balance the load for all of these users. Also, they create in API gateways, microservices world, for example. One balancer will route payments and the search services to different internal services. I guess we can wrap up. So that's a beginner-friendly tour of load balancers. The unsung heroes keeping our internet speedy and reliable. Might in the next video I might talk about layer 4 versus layer 6 in depth. But yeah, I'm not so sure if I'll do that or not, but like hopefully I will do that. So yeah, that's it for this video, and see you in the future, guys.